So talking about differential rotation, that means different parts of the sun rotate at different speeds. So a day on the sun at the equator is less than a day if you're further out. Not the case on the Earth. Now, this happens whenever you have a gas or a fluid, because the fluid doesn't have to rotate at the same speed. And the equator is actually spinning the fastest, and it gets slower as you go out. The Earth, that couldn't work because we're a solid body, and if the equator was going faster than the poles, the whole Earth would rip itself apart. But whenever you have a gas ball that's spinning, you're going to have this differential rotation. Now that affects the magnetic field. So imagine this. Here's the north pole of the sun, here's the south pole, and it has a north magnetic pole too, and a south magnetic pole, just like the Earth. It's not exactly lined up with this north and south pole, just like ours isn't. We have magnetic fields that our magnetic pole is not exactly on the north pole. But what happens is the sun is spinning, and it's spinning faster at the equator than at the poles. So after one rotation, what we see is, and for simplicity I'm going to put the magnetic pole right on the north, but the magnetic field now is going to go like this. It's going to get stretched out because the equator is going faster than the poles are going. So it's kind of like having a string, but you're pulling on the center and stretching it around because the center is going faster. So one rotation, though, not a very big deal, but what if you do after many rotations? Well, then the magnetic field of the sun actually gets wound up. Gets all twisted. And if you're going to put a compass on the sun, what would happen is your compass, instead of pointing to the north, would actually point towards the east. Or to the west, depending on which way whether you're doing the north or the south pole. So what's happening is the magnetic field. So again, if you imagine your string on each end, and it's a stretchy string, and you have a ball in the center, you're just winding the string up around the sun. But when you get it wound up like that, then it starts to pop through the surface in different places. And when it pops through the surface, you get this cooler gas in blobs here. Those are sunspot groups. All right, so this is what we think happens. Is what we find is the sun goes from a very quiet magnetic field, where the magnetic field is just going straight north to south. When this occurs, this is at sunspot minimum. Or what we call the quiescent sun, very quiet, nothing's happening. No sunspots, very uniform. Corona's nice and smooth. But then it gets wound up. And it gets wound up, and it gets totally wound up like this, and we have sunspots popping out all over. This would be at sunspot maximum. Then all those sunspots get all wound up, and then they fade away. They actually migrate. And then the next sunspot minimum, the magnetic poles flip. And then we go through another sunspot maximum. So this is very confusing. Because what happens is, we have north up here, south up here. This is the magnetic pole. And then 11 years later, it flips, and it seems to flip during the minimum. So during sunspot minimum, it flips, and then when the sunspots come back out, they're going the opposite direction. Your compass would flip around and look the other way. And then 11 years later, it flips again, and you're back to north and south. So what we call the magnetic cycle of the sun is actually 22 years. Because you have to flip, and then you got to flip back to get back to your original configuration. So the magnetic cycle of the sun takes 22 years. But the sunspot cycle is 11 years because you get a maximum in between every one of them. Yeah. What's making the magnetic field of the sun flip every 22 years? We really don't know at this point. Now the magnetic fields flip. We know the Earth's magnetic field has flipped in the past, but ours flips on the order of thousands of years. It takes a really long time to flip. And our magnetic field is created by our liquid core. Definitely the magnetic field of the sun is created somewhere down inside the sun, but it's hard to explain how you go from north to south. North to south, when it's spinning this way, is because when you take a charge and you spin in a circle, you create a magnetic field. But when you flip it over, the sun doesn't stop and rotate the other way. It's still rotating the same way. So what's making it flip over has to be some kind of eddy currents or something going on deep inside the sun. So we're not really sure. Astronomers are still working on that. But it does create this magnetic cycle that lasts for about 22 years. All right. That is it for the sun. A lot of material. But the sun, by far, is the star that we know the best about because it's so close and we've been studying it for so long.